Alright, so well, today my voice is a little bit deeper. I'm having some flu, but don't worry, not corona. Alright. Last part of your chemistry, chapter 4, transition element. So this part is a very short part. You're not going to learn in detail about your transition element, just a few what they call physical properties, and then that will be it. Alright, so for your transition elements, okay, so the example that you're going to learn is okay. So here is your transition elements. Alright, here are your transition elements. Okay, so the one that you're going to learn in detail. Okay, technically, they want you to know the first row lah. Alright, starting from scandium until zinc. Okay, this one of course you must know. Alright, scandium, titanium, vanadium. Okay, until zinc, and then a few important transition elements that you might need to know. Maybe a few one is this one, molybdenum. Alright, and then let me see. Okay, these three, palladium, silver, and cadmium. Okay, you just need to know the names. Alright, tungsten. Okay, tungsten normally is used for your light bulbs. Alright, if you look at your light bulbs inside, you have a coil, right, like a wire thing. Okay, that is made using tungsten. Okay, and then you have your platinum, your favorite gold, and also your mercury. Alright, so these are the few transition elements that you must know. Okay, the chemical symbols and their names. Alright, so for transition elements, the only thing that you're going to learn here is actually the physical properties. Alright, so for physical properties, there are a lot here. So I'm going to tell you which one are the important ones for transition elements. Okay, they have four very special ones for transition element. This is the first one. Right, they form colored compounds. They have more than one oxidation state. They form complex ion and use as catalyst. Alright, so technically, in your periodic table, transition elements are special. It's because most of them, when they turn into ions, they will give you different colors. Alright, and then more than one oxidation state. The meaning of this one is actually this. Oxidation state is referring to different charges. Alright, meaning one transition element you will have different charges. Okay, so for example, maybe for iron, alright, iron you can have 2 plus, 3 plus, alright. Previously, the one that we had learned, period 1 until period 3, their ions are fixed. Okay, meaning that each element will only have one ion, but for transition elements, they are different because each element, alright, each element here, okay, will have different, what do you call, ions or different charges. So for like titanium, right, they can actually form 2 plus or 4 plus, alright, or 6 plus. Okay, whereas for iron, alright, sometimes iron, they can form 2 plus, or they can also form 3 plus. So it depends on the element. So each, so basically normally all the elements here in the transition, what they call element, they have different charges. So this is what we call oxidation state. The meaning of oxidation state is that they have different charges. Okay, alright, complex ion later I'll show you, and catalyst. Okay, so let's just look at the part here. Alright, so special properties. This one is, you must know this. Alright, special properties for transition element. Okay, so the four that I've highlighted just now, you have many different oxidation number. So this one is for chromium. Okay, so this one, plus 3 plus 6, this one is referring to the chromium here. Alright, so technically chromium you can either get 3 plus or 6 plus. Alright, for manganese, okay, manganese, right, you can have 4 different charges or 4 different oxidation states. Okay, this one is for iron, this one is for nickel, this is for copper. Alright, so as you can see here, okay, iron you can have 2 different oxidation states, copper you can have 2, manganese you have a lot, you can have 2 plus, 4 plus, 6 plus, and even 7 plus. Alright, so this is what we mean by many different oxidation numbers. Okay, now the second special characteristics for transition elements are they form color compounds. So different ions will give you different colors. Okay, so chromate ion will give you yellow. So are you going to memorize everything? Of course not. I'm going to tell you a few important ones, okay, that you must know. Okay, okay, dichromate ions and permanganate ions. Okay, orange and purple. All right, this one of course must know. Iron 2 plus and 3 plus, you will get green and brown. Okay, copper. This one is the most famous one that you must know. Copper 2 ions will give you blue color. Okay, and then cobalt and manganese will give you pink. Right, chromium. Okay, chromium will give you green. Okay, so those are the few important what do you call transition element ions that you need to know. Okay, what color they will give. Right, this one you must memorize. You have no choice. Okay, we need to remember the color. Okay, especially for copper 2 ions. Okay, this one is the most famous one that you must remember. Blue color. Okay, and then if you notice your stones, okay, ruby, sapphire, emerald, amethyst, so what are all these things? Okay, many different stones, they have many different colors. It's because of the transition elements inside the stone. Right, so a lot of things in your daily life, okay, you will see a lot of uses of your transition elements. Okay, so this is one example of the uses of transition element. If we make it to use if we use it to make it to use it to make colored glasses. All right, so if I want to make a glass which is green in color, I can either use 2 plus, iron 2 plus, or chromium 3 plus. Okay, and then you have cadmium, okay, cobalt, uranium, alright, but this one will be radioactive. You don't make a glass out of uranium, okay, you're going to get cancer. Right, and then many different, okay, copper, like bluish in color, alright, and then other examples of color compounds that we use, for example, this one. Okay, I'm sure you have seen this before. All right, windows. Okay, windows that are colored. Right, these are not painted. Is when they manufacture, they put in the transition element that they want. For example, if I want it to be green, I can either put in the iron 2 plus or the can either put in iron or the nickel. All right, so I can get the green color. If I wanted the bluish tint here, I can put in the copper ions. Okay, so this one you can see where is older houses last time uh, during not my era my grandmother's era, their houses, their window panes are made of using this one colored. Okay, or if you want to see this, you can go to church. Okay, any church that you go in, right, you will see a lot of these colored windows. Okay, they have a lot of all these colored windows in your churches, right? So you can see all these things. Okay, so these are colored because when they manufacture the glass, all right, during the process they add in the transition elements. So the transition elements will give you the color. Okay, all right. And then another example is this. Okay, your favorite artists, all right, your hair color. Okay, natural hair color, for example, not example, natural hair colors. If you are naturally blonde or naturally brown, of course that is because of your melanin, right? Your melanin, your U melanin or your pheomelanin. But colored dyed hair, if you want to dye your hair, all right, the chemicals that you use, okay, they contain a lot of transition elements, not a lot, all right, a touch of transition elements. So you can see here, right? This one is brownish in color, right? So most probably you will have what maybe iron inside, uh, maybe a little bit of cobalt, okay, all right, or maybe the mix a little bit of what we call copper in, okay, pink, all right. This one maybe you have molybdenum, all right, or maybe cobalt, okay, or Taylor Swift with the blue hair, right? Blue, yeah, maybe you have copper ions inside as well. Okay, and then of course you have many other things, right? So these are just few examples of your uses of your transition elements. Okay, then all right. So okay, precious stones. Oh, ruby, sapphire, emerald, and amethyst. What is the amethyst? Some might not have seen an amethyst before. Let me just search this for you. All right. Okay. Okay, so this is amethyst. All right, the one that you always see in feng shui stores. Right, you will see all people selling all these things. Okay, now so the purple in color is because of the manganese ion. Alright, ruby, sapphire, I'm sure you didn't know all those things, right? So all your precious stones, they have colors. It's because of your transition element. Okay. Okay, so ruby, the color is red is because of the chromium ions. Now, of course, although we see here that the chromium 3 ions, they give you the green color, right? But in certain situations, it depends on what happens in the chemical reaction. Okay, there's a particular reason why this one, the ruby, the color is red. Okay, this one is a higher level of chemistry that you need to learn in your university. All right. So just remember the what you call transition elements that you have for different types of minerals. Okay, so for catalyst, the meaning of catalyst here is that your transition elements, what they do is they speed up the chemical reaction, right? Meaning they make the chemical reaction go faster. Okay, so you have iron powder, vanadium oxide. Okay, the transition element here is this one, vanadium. Okay, that is your transition element, nickel and platinum. Right? For this part, you don't have to worry. You're going to learn in detail all these things in chapter 8 or chapter 9. Right? So just remember the function of your transition element, okay, as a catalyst. Alright, so for the next one is complex ion. Okay, the meaning of complex ion is that your ions are not in simple ions. Simple ions are like the one that we learned, sodium chloride. You have one positive ion and one negative ion. Okay, or let's say for example you have your potassium nitrate, KNO3. Alright, and then you have one positive ion and one negative ion. Okay, these are simple ions. Now in this case, alright, if you notice the amount of ions here, you can see here, this one I have 4 of the NH3. Alright, this one I have 6. Alright, so this one I have 6. Okay, so as you can notice that these ions are not the typical ions that we learn. Okay, that's why we call them as complex ions. Alright, so don't worry, you don't need to memorize this, you just need to know that they form complex ions. So those are the 4 important properties of your transition elements. Okay, and then the next thing you need to know are their uses. Alright, so titanium. Okay, titanium alloy. Okay, the meaning of alloy is that I mix different metals. Alright, so technically alloy, the meaning is the mixture of different metals. Alright, meaning I take different metals and then I mix them together. Alright, okay, so meaning the titanium alloy, most probably they added in a little bit of maybe chromium or other things to make it, depends on what is your application. Alright, so titanium alloy, this one is used for orthopedic, okay, because it does not corrode. Alright, okay, you don't want to put in a metal inside your body that corrodes. It'll be funny, right? Okay, and then gears, alright, your car gears, motor gears or whatever. Alright, okay, so this one you're using vanadium steel. Alright, and then again titanium alloy. You see the function of titanium alloy is a lot. Aircraft, okay, they use titanium alloy because it's light. Okay, so light and highly resistant. Okay, that's why we can use it for your aircraft. And then coins, normally we use nickel. Okay, nickel or copper nickel, right, depends. If you want it to be brownish, alright, then you put in the copper in, then it turns into brown color instead of a silver color. Okay, and then chromium, you know your stainless steel, right? Okay, your stainless steel, normally they use a lot of chromium, right? Some high-end stainless steel, maybe they put in they mix more, right? Stainless steel, chromium, maybe a little bit of iron. Alright, so a lot more. Okay, this one is for construction. Okay, normal steel is iron. Okay, the normal steel that you use for what they call construction. Okay, we call them iron. Not call them iron, it's actually iron. Alright, so as long as you see the word steel, it's actually referring to iron. Okay, so copper, this is the most widely used transition element. All your electrical wirings are using copper. Okay, So those are the few examples of your transition elements. There are many, many more, right? Your handphones, okay? Why you can have such high definition screen? Why the color is so bright? Okay, they incorporated a little bit of your rare earth metals into your handphones. Okay, that's why you can see the bright colors inside from your phone, right? So typically that is it for your transition elements. All right, that is it for chapter 4. Okay, so I'm going to show you a few examples of questions and then how to solve these questions. All right, so let's look at the first one here. Okay, shows the electron arrangement of P and Q. All right, so they are placed in the same group. Remember, if you want to know is which group, okay, what do we refer to? We refer to the valence electron. Alright, meaning we look at the outermost electron. Okay, so here the outermost electron is this one. Okay, outermost electron is, this is the outermost electron. So I only have one valence electron. So I am in group 1. Okay, how are, not is answer should be R. How are elements P and Q kept in the laboratory? So group 1 are metals, okay, alkaline metals, right? Remember, metals, they are reactive towards oxygen and water. So we need to keep them in paraffin oil. Alright, so basically they are kept. Alright, does this thing get up here? Okay, basically they are kept in paraffin oil. Okay, so reason basically is to avoid exposure. Alright, because they are very reactive. Okay, or another way that you can write it is that the reason why we put it in paraffin oil is because they are very reactive towards oxygen and water. Okay, maybe that one will be a better answer lah. Alright, so first P and Q, okay, very reactive towards oxygen and water. Okay, so just remember the reason why we put in paraffin oil because we don't want it to come in contact with oxygen and water. Alright, write chemical equation between P and water. So this one is a reaction between group 1 element and water. Remember, you're going to get alkali and hydrogen gas. Okay, you need to remember the equation. For group 1 elements, if you react with water, you're going to get alkali and hydrogen gas. So how can I write the chemical equation? Now, first things first. Here they put P, right? So I just follow what is given here. Okay, so P react with water, then I will get alkali. Alkali meaning it becomes OH. Okay, remember OH, alkali is referring to OH. So plus hydrogen. Okay, now when you write a chemical equation, the first thing that you need to check is the balancing. Okay, so we need to balance. So this one is 1p balance, 1 oxygen balance, 2 hydrogen, but here I have 3 hydrogens. So very obviously, alright, since this one is even number, this one is odd number. Remember the method that I teach you, you change the odd number into even number. So I put 2 here. Alright, since I put 2 here, meaning this one will become 2p. So here I need to put 2 as well. And then the oxygen also in front I need to put 2. Since I have 2 oxygens here. So let's check for the hydrogen again. 4 hydrogens, 2 hydrogen plus 2, 4. And then the rest are balanced. So this is your balance equation. Okay, right, next one. What is the expected change of color when a few drops of phenolphthalein? Alright, so remember your phenolphthalein is your indicator. So you need to remember the color change for phenolphthalein. So if from acid to alkaline, okay, phenolphthalein, your color change should be, okay, in acid phenolphthalein colorless, but in alkali it changes to pink. Okay, so if you choose this one, I'm producing an alkaline solution, right? Meaning my color change will be, remember, question is asking you change of color, meaning you need to mention from what change to what. You cannot just mention pink, okay? Cannot, alright? So you need to say colorless to pink, and then when they ask you to explain, okay, because the solution is an alkaline solution, alright, because you produce an alkaline solution. So normally students' mistakes will be where is the change of color, alright. Sometimes you only write pink, you never say from what change to what. Okay, so this one is like very detailed. If they mention change of color, you need to mention from what change to what. Okay, that is the safest answer. Okay, you won't get wrong if you write like this. Right? Okay, between element P and Q, which is more reactive? Okay, now remember reactivity. Okay, reactivity depends on the valence electron. Okay, remember, reactivity of group 1 elements depends on how easy you release the valence electron. Okay, and then remember, here the distance is shorter, here the distance is further, right? So the further the valence electron away from the nucleus, meaning the force of attraction is weaker, right? So it's easier for the valence electron to be released. Therefore, Q will have a higher reactivity compared to P, right? So, which is more reactive in the reaction with water? Q is more reactive than P. Okay, here comes the most important part. Explain, okay, why Q is more reactive than P. So, this is very important. First point that you always write, you always start off with this one, size. Okay, you always say size of which one is bigger than which one. Alright, so atom Q is bigger than P. Okay, so after you mention about the size, second point that you need to mention is the valence electron. Okay, so we say that the valence electron of atom Q is further from the nucleus, okay, compared to P. Alright, and then the point, after you mention valence electron is further, you need to mention what the attractive force. Okay, so I like to write this nuclei attractive force, okay, between valence electron and nucleus in atom Q is stronger than P. Right, so point number 4, we can say that easier for the valence electron for atom Q to be released. Alright, so technically you have 4 important things that you need to write in your answer. Alright, first you need to mention about size. Okay, after you mention about size, you talk about the valence electron. Okay, further or nearer from the nucleus. Okay, and then apply attractive force. Okay, which one is stronger, which one is weaker. Alright, and then finally your conclusion. Okay, whether it's easier to be released or more difficult to be released. Okay, so these are the few important things that you must have in your answer. Alright, okay, so the final question here, name one element that has same chemical properties. So remember, if we say same chemical properties, it's because they have the same valence electron. Okay, so if same chemical properties, meaning you must have same valence electron. So since I already know this one is group 1, right? Okay, so they want me to give another example of group 1. But here is where it's important, name. Okay, name, meaning I must say is what element. In this case, I know that this one is lithium, this one is sodium. Okay, based on the what they call proton, the electron, I know which elements are these two. Alright, so they want me to name another one other than these two. Okay, so we just give any example. Alright, so potassium, okay, or cesium or francium. Alright, so that is the meaning of this question. Okay, so technically that is how you solve the questions. Alright, okay, question 2. Okay, write electron arrangement, okay, based on the proton number here. Alright, so state position, okay, this one they always ask in your exam, state position. Okay, so let me just show you one example. So I have 9, my proton number here is 9, so my electron arrangement will be 2, 7. So if I want to know the position, remember, I need to write the group and the period. So group will depend on your valence electron. So since this one is 7, remember 3 to 7 we need to add 10. So this one is 7, so it's group 17. Okay, this is like a revision for those who already forgotten everything during the MCO. Alright, here which period, how many shells? So I have 2 shells here, so period 2. Okay, alright, and then again same chemical properties. Okay, remember I did mention on top, you see whether they have the same valence electron. Alright, state the type of particles. Okay, for W and X, based on the proton number, right, you will notice that they are at the right side of the group. Okay, so you know this group 17, this is actually group 17, and group 17 elements normally they form molecules. Okay, right, they must be diatomic. Okay, so meaning they form molecules. Alright, okay, and then what else? Let me see. Okay, compare boiling points. Okay, now if they ask you to compare the boiling point, okay, compare boiling point, okay, explain the differences. So first thing you need to mention which one has the higher boiling point, W or X. So you need to say W is higher than X or X is higher than W. You cannot just say W because they put here the word compare. So your answer, the most accurate answer will be which one higher than which one. Okay, that is your first point here. Okay, explain. Now when they ask you to explain the differences, right? Three things you need to write. Okay, boiling point is almost the same. So the first thing you write about the size. Okay, second point, you're going to write about the attractive force between molecules. Alright, so attractive force between molecules. Okay, so in either we write the attractive force or we talk about the van der Waals forces. Okay, you can mention the van der Waals forces between W is stronger than X. Okay, or vice versa, which one? You need to depend on the question itself. I'm just giving you an example. Alright, so you need to determine which one the van der Waals forces is higher, okay, or the attractive force. Okay, and then after that, only you mention the final point. Okay, whether more heat or less heat is needed to overcome forces of traction. Alright, so 3 points here. Alright, your explanation will be depending on these 3 points here. Okay, so if you say boiling point higher, okay, why higher? So you are going to need more heat to overcome the forces of attraction. Right, so try and complete the exercises. Okay, then again they ask about the reactivity. So this one is group 17. So you need to remember group 17, the reactivity is different than group 1. So is it increasing or decreasing as you go down the group? Alright, so refer back to the notes. Okay, so those are the few important things that I would like to touch about your chapter 4, your questions. Alright, okay, so that is it for today. Bye.